Today we will learn what is regular expression and what are its properties. Right. So after learning regular expression, we will be able to know what is regular language. Fine. So firstly, let us know why we need this regular expression and what is the need of regular language. Here, regular language in other sense is also called the language of a DFA. Why? Because this deterministic finite, or we are concentrating on this deterministic finite automata because ultimately the improved form of a NFA is DFA, right? So ultimately our goal is to convert a NFA to DFA so that we get some determinism in our machine, whatever we have designed so far. So the language that a DFA can accept means the strings that DFA can process are false, that all those strings or all those things falls under your regular language, right? So as we all know, here we are defining one DFA named A. Obviously it is a 5 tuple machine, Q sigma delta Q naught F, and the language is denoted by L of A, means whatever the language this DFA can accept, it is a language of that DFA. That's why L of A, and it is defined as this. The syntax, the methodology is given how to write the language of a particular machine, and what it means. This language of A is a set of strings W that take the start state Q naught to one of the accepting states. We all know that whether a string is getting accepted by a finite machine or not, that depends whether that string can be generated by starting from the initial state and whether we are able to ending at one of the final state or not. If we can make the string starting from the initial state and can bring it to one of the final states, then our job is done. That means we can say that this string is getting accepted by the finite machine, right? So if L is LA for some DFA A, then we say L is a regular language. So if we can make any of the strings that this language can generate accepted by the DFA, then we will say that language falls under regular language, right? Next we will focus on regular expressions, because without knowing what regular expression is, you will be not be able to know what regular language is. Okay, so here first, epsilon is a regular expression, indicates that language containing an empty string. Please keep the difference. Keep in mind what is the difference between L of epsilon and L of phi. Okay, two things are different. One is containing an empty string, right? But L of phi contains nothing. It's null. Okay. So it is empty language. But if we are given L of epsilon, we will say it consists of an empty string. And L of phi, if we say it contains nothing, it's an empty language. Okay. If X is a regular expression, what is the language? X. In this fashion, we will see more examples. Now, if X is a regular expression denoting the language L of X and Y is denoting L of Y, then all this condition holds, and we will see the proof of each and every steps. Fine. So, if we add up two regular expression X and Y, that means ultimately in form of language, if we express that X regular expression to L of X, means what is the language it is generating, and if that Y regular expression, if we convert that to L of Y, that is what language it is generating, then ultimately that addition of those two regular expression will be equivalent to the union of two that regular language. Means adding up to regular expression will generate the union of two individual regular languages. Similarly, if X dot Y is a regular expression, then if we find out intersection or dot of, means dot means here ending, intersecting, nothing else, so dot of that two regular expression or that two language will be equivalent. Then R star is a regular expression corresponding to the L of R star, then this L of R star is equals to L of R whole star. What is the meaning of this? It is nothing but it is following the closure property, right? It is closed. you all know in group theory, we have learned what is in groups, what is closure and what is all. So it is closed under this operation. Now let us see some examples. Here one regular expression is given and we are generating the regular set. That means how to write in form of language. If regular expression is given 0 plus 1 0 star, what is the meaning of it? Star means it will include everything including null. So here the regular expression means either it will be 0 or, since plus is there, so or it will be 1 followed by any number of zeros, right? The meaning of this is like that, 0 or 1 followed by any number of zeros including 0 number of zeros. So what can be the regular set? 0, we are taking 0, then 0 is done. So now we will form the combination of the second string, that is 1 followed by any number of zeros. Firstly we are keeping no number of zeros, so 1. After that we are keeping 1 0, so 1 0, then 2 zeros, so 1 0 0. In this fashion it will follow. Next another example is given, 0 star 1 0 star. So what is the meaning of it? Middle means 1 will be there, it can be preceded by any number of zeros, it can be followed by any number of zeros, and that number can be null as well. So this minimal string can be 1, then what can be another string? 0 1. What can be another string? 1 0, right? On 0 1 0, then 0 0 1 0 or 0 0 1 0 0, anything. Next is 0 plus epsilon into 1 plus epsilon. What is the meaning of this? This is empty string, so it can be either 0 or null for first, then 1 or null, right? Or 0 or 1 or 0 1, anything like this. So firstly it can be empty because we are picking up empty from the first 0 plus epsilon, and again we are picking up empty from 1 plus epsilon, so it will be empty. Now we are picking up 0 from the 0 plus epsilon and we are picking up epsilon from 1 plus epsilon, so it will be 0. Then the reverse, we are picking up epsilon from 0 plus epsilon and we are picking up 1 from 1 plus epsilon, so it is 1. Now we are picking up 0 from the first and 1 from the second, so 0 1. So this much can be done, we cannot proceed anymore. Next, a plus b whole star. What is the meaning of this? Set of strings of a's and b's of any length including the null string, because star is there. So it can be epsilon, it can be a, it can be b, it can be aa, it can be bb, it can be ab, anything, any combination. Similarly for others you can just follow the chart and you can try out many more examples. So I think now it is clear how to convert a regular expression to regular set, and that is a language only. Fine. Okay. Now we will one by one. Firstly, we have to prove that the union of two regular set is regular. So for your convenience, I have taken small examples and I have proved accordingly. First regular expression is a dot aa whole star. So what type of language it will generate? It will contain single a first, then it can have any number of a's which is divisible by 2. Fine. So a star means either it can have no a's, it can have 2 a's, it can have 4 a's, it can have 6 a's, and so on. And always this string will be of odd length, obviously, because a single a is there. And RE2, that is regular expression 2, is a star, means it will always be of even length. It can be null, it can be 2a, it can be 4a's, it can be 6a's, and so on. So in that fashion we have written L1 and L2. And so if we concatenate, what will be the answer? Means it will contain all odd length strings and also even length strings, and obviously empty string. So empty string, then say we are arranging in that manner, one odd, another even, one odd, another even. So if you follow the pattern, this will be like this, L1 union L2, and this is the strings of all possible lengths including null. So if you write it in again in form of regular expression, means L1 union L2, what will be the answer? It is A star only, because it is any combination of A including null. So it is obviously a regular expression. So we can prove that the union of two regular set is regular. Next we will see the intersection of two regular set is also regular. I have taken again two examples of regular expressions. One is A into A star, another is A whole star. So first language will be like this, A and empty for the A star. Then I am keeping one A from the A star, so it is AA. Then I am keeping two, then AAA, and this fashion it follows. It is a combination of all the strings, just excluding the null, because one A will be always there. And regular expression 2 will generate even length strings including null. So if we do the intersection, what will be our outcome? Only the even length strings. So it will discard the empty, because there is no empty string in L1. It will discard it and only take up the events from the L1, and L2 is there with the events only. So this is a string of even length. So what the language we can write, or what is the regular expression we can write of this intersection value? So 2A is mandatory, minimum length should be 2A. So AA followed by AA whole star. So this is also a regular expression, hence intersection property holds. Okay. Next we will see the complement of a regular set is always regular. Okay. Then how to find out the complement first? So we are taking, say, one regular expression AA star. So what is the language it is generating? Empty string AA, 4 A's, 6 A's in this fashion. So it is the strings of even length including null. So complement will be non-even length strings and excluding null. So it will be obviously A, then 3 A's, then 5 A's, and so on. So again, if we write it in form of your regular expression, what is the minimal string? A. And then what can be the repetition? Double A whole star. So this is also regular expression. So the complement of regular set is also regular expression. Okay. Next we will see the difference of two regular set is regular. We have taken one regular expression named A star, and another regular expression AA whole star. Again I am writing the language, hopefully you can understand now. See, in the same way for both. Now if we want to subtract L2 from L1, what are the strings it will contain? First, L1 is containing all the strings excluding null, and L2 is containing only the even length string including the null. So our set will contain only odd length strings excluding null, because we have eliminated L2. So it is, if we write in form of expression, again it will be A followed by AA whole star. So it is again a regular expression. Okay. Next is the reversal of a regular set is regular. So we have to assume one language first. Let us say our language is 0 1, means these 4 strings can generate, our DFA can generate these 4 strings. This is our assumption for now. And all the proof what I have explained so far, you can try out with any of the regular expression. This is just one of the example. You can try it out with any of the regular expressions of your choice. Okay. So coming back to this, L equals to 0 1 1 0 1 1 1 0. So if we write it in the form of regular expression, what it means? It may contain 0 1, it may contain 1 0, it may contain 1 1, it may contain 1 0. So if we reverse the strings, what will be the result? 0 1 will get reversed, that is 1 0. 1 0 will get reversed, 0 1. 1 1 will get reversed, will become 1 1, and 1 0 will reverse to 0 1. So here what is the expression coming? This plus this plus this plus this, and which is again the regular expression. So this is also proved. Now property 6 says the closure of a regular set is regular. So firstly we will select we are not writing the regular set beforehand. Firstly we are writing the language. It is a means 1a followed by even number of a's, any combination of even number of a's. And closer means what can be the means superior version of this, or you can say what can be the superset of the of this language. So it can be any combination of a, right? So means excluding the empty string, because our original language is not concentrating on the empty string. So here it will be a, double a, triple a, and so on. So if we write it in the form of regular expression, it will be a single a followed by any number of a's. So again this is a regular expression. So again the property holds. Next, property 7 says the concatenation of two regular sets is regular. Our first regular expression, what we have assumed is 0 plus 1 whole star followed by a 0, and regular expression 2 is like 0 1 followed by 0 plus 1 whole star. So the language generated by first regular expression will be like this one, you can easily make it out, and similarly L2 will be like this. If we concatenate these two, means L1 followed by L2, let us focus on 0 of L1 first. So 0 combined with 0 1 makes 0 0 1, then 0 combined with 0 1 0 makes 0 0 1 0, and in this fashion you can make the combination. So whatever the outcome will be, it will be like this. You can say the smallest, what is the smallest string or what is the substring that is mandatory here, that is 0 0 1. So it will be, there should be 0 0 1 in the string, and it can have any number of 0, any number of 1s, and anything, or there cannot be as well. So it will be 0 plus 1 whole star, means the combination of 0 1 and 0 0 1 again followed by 0 plus 1 whole star combination. It is again a regular expression. So you can say the concatenation of two regular set is regular. Next we will see some identities related to this regular expression. So you can just go through this, and if you want to prove it out, you can take any example and you can prove it out. Okay, so the empty string, whatever the combination you do, it will ultimately result in a empty string, means 5. Similar for empty string, if you write r dot r star, means any r, any expression followed by the another expression a multiple number of times, the reverse is true as well. If we write the say anything a star dot a star, that means a star only, right? So r star dot r star equals to r star. Similarly for all other, you can just look it out, and if you are unable to understand, please take any example and just work it out, it will be done. Okay, few more identities are there and some names are here given. So r plus phi equals to phi plus r, means r plus any phi obviously equals to phi plus r, and that is r only. This is called identity for union. Then next is concatenation. If we multiply any empty string with the r, the reverse is also true and it will ultimately generate r. So in this fashion you can see the important law, left distributive law, right distributive law, if these are identities present. So if you want to go to the proof, take any example of regular expression and put it there, you will be able to prove it. Okay, and this is the end of lecture. Next class we will learn what is Arden's theorem. This is a very important part of regular expression, and few examples associated to Arden's theorem. Thank you.